Ta-da, two-dimensional arrays. The last section we want to cover. Uh, Clearly, we don't have time to write a program to spend a bunch of time with it. But for those of you that are comp-sci folks, you're going to need to know how to work with two-dimensional arrays. Okay, so the first thing we should take a look at is, how do I declare a two-dimensional array? What does it look like? So the declaration is, instead of, like we previously saw, one set of square brackets, I now have a second set of square brackets. Now, what's a two-dimensional array? Well, you start taking a look up here, and it's where I have the good old-fashioned rows and columns. I wrote spreadsheet, a matrix. You know, some of you have done math matrix work. That sort of has fizzled, the importance of working with matrices. You don't see it as often as you used to, or as early as you used to, like it used to be done in college algebra. But I start to take a look at rows and columns. Columns hold up a building. Columns go vertically. Rows go horizontally. So at this moment right now, if I called this matrix score, this guy right here would be scores sub 0, 0 equals 4. And if I did scores sub 2, 1 equals 5, that means I would go to row first, row 2, column 1, and this would be location 5. So it's similar to a regular one-dimensional array, but instead it's two-dimensional. And there are times where this is an idea we want to work with. You could go with a three-dimensional array. One time in high school, we used to have final projects, and the one student wanted to do three-dimensional tic-tac-toe and write the program. And of course, there clearly were lots of if statements he needed to know. You know, if you were playing tic-tac-toe, if you wrote that program, how many ways are there to win?
9.
I'm going to say no.
8.
8, yeah. 3 horizontal, 3 vertical, and 2 diagonal. Unless you were doing like postage stamp or something, I don't know. You go to the bingo parlor much or not? All right, so again, here's a declaration of what a two-dimensional array should look like. So how would I traverse through this two-dimensional array? Well, I'm going to do that by using 2 for loops. And of course, inside here, I may have some kind of simple printout. But how do these 2 for loops look? Well, here's how we go. I go row 0, do my outer loop. Then I come inside, and in the body of that for loop, column is going to get the values of 0. So if I'm in here, I stay inside that inner loop. Column also would get the value of 1. That outer loop of row wouldn't change. And column would also get the value of 2. So it would go through here 3 times inside the inner loop. Now, when I'm done, I would come back out. I'd go back to the for loop. It now jumps to 1. Comes to the inner loop, starts all over again. It would go 0, 1, and 2. And if I kept going, next iteration, go to the outer loop, it's 2. Inner loops restarts again to 0, to 1, and to 2. So by using these nested loops, I can come through and access what's going on in here. I could say system.out.print the scores, my array, at each one of these subscripts. Now you notice when I come out, I have a println. What's the purpose of the println? Well, these scores would look nice printing side by side. And then when I come out of my inner loop, I'd like to put in a println so that it does a carriage return. So the next group of numbers would come out side by side. And we're going to actually use this today. That's one of the three methods you're going to write. Last thing to take a look at is, can I implicitly initialize a two-dimensional array like I did a one-dimensional array? And the answer is yes. As you see here at the bottom, I have my set notation, and then within each set, I have sets. So I just created the array 1, 2, 3, next row 4, 5, 6, next row 7, 8, 9. So I'm able to fill it implicitly. Questions? Now, if I go back to D2L and I go up here, what I'm giving you is the main for a program that's going to work with two-dimensional arrays. You notice I declare, I just always wanted to say that. I declare three matrices: matrix A, matrix B, and matrix sum, all the same size. Now you notice how I do this. I call the method fill, and I'm going to use that to fill matrix A. I call the metric fill. This time I'm going to fill matrix B. What do I want to fill these with? I like to fill them with random numbers from 0 to 9. So fill is going to fill random numbers 0 to 9. Print. Well, I'd like to see what A looks like. Print. I'm reusing these methods. I'd like to see what B looks like. Even down a little bit lower, I say print matrix sum. So that's my second method. My third method is there in the middle. Add matrix. I'm going to pass in A, pass in B, pass in sum, and I'm going to go through and add the two together and put them into sum. How do I add them? Row 0, column 1 gets added to row 0, column 1, and the result gets put into row 0, column 1 inside of matrix A. Questions?